Good afternoon, or good morning, or maybe even good evening, everybody. Welcome to this live Q&A about PCI DSS version 4, and also I'm going to talk a bit about mastering JavaScript security. Today is really an Ask Me Anything as well. So I'm going to do maybe a 5 or maybe, I don't know, maybe an 8-minute presentation. And then at the end, we'll take questions either on managing JavaScript, some of the issues we've seen ourselves with complying with the new PCI DSS requirements, and any questions about PCI DSS 4 that you have. So I'm going to start with a very tiny presentation. Not that I know how to do that. I'm going to press magic buttons, and hopefully you will start seeing my slides. Yep, that's cool, isn't it? It's like magic. And so, yeah, introductions first. My name is John Elliott. I'm a security advisor at JScrambler. And previous to that, I was MasterCard's representative on the PCI Security Standards Council's working groups. And so I helped write bits of PCI DSS version 4, along with other talented people from the card brands and the PCI SSC. As we know, PCI DSS version 4 is the first big version of PCI DSS since version 3 came out in 2015. It's here because the world changes, the way we do technology changes, the attacks against our infrastructure change, the way we do infrastructure has changed, with Kubernetes and cloud and things like that and containers. And so basically the standard has to change. The criminals change the way they attack. We change the way we accept payment cards. And so part of it is there are clarifications and changes to the way that people do validation within the standard. But the other thing that's really important is there are 64 new requirements. Some of those new requirements come into force straight away, and others of them come into force in 2025, as we can see from here. So hopefully you're all working really hard to do your transition from version 3 to version 4. Interestingly, JScrambler is going through that exercise at the moment, and sometimes it's really interesting because our QSA says, "Have you done this?" And it's like, well, that's not in version 4 anymore. So it's quite funny that some of the QSAs are also getting to speed with this. So I guess you're having exactly the same experiences that we are. But version 3.2.1 gets retired on the 31st of March next year, which now isn't very far away. I know it says 2024, but it sounds very far away. And then the 51 new requirements that require you to either do capital expenditure or make technical changes come into force on the 31st of March 2025. And I know 2025 sounds an awful long way away. But if you're in an organization where you need to buy something and get budget to make some of these changes, and for instance, mandatory MFA for all of the CDE will mean that if you haven't got MFA, you need to buy an MFA solution, then you probably need to start scoping and costing that now, because to get budget and to get a change window to have it in place by the 31st of March 2025, really that needs to be done today. Before I was at MasterCard, I worked for a very big airline, and if I wanted budget to spend something in 2024 and to get a change window to do something technically, that's something that requires a lot of planning. I want to talk about, unsurprisingly, because of what JScrambler does, the new anti-skimming requirements in PCI DSS version 4. And the reason we have new anti-skimming requirements is, of course, because that's the major way that cardholder data has been stolen from an e-commerce environment. When I started in the industry, which now is far too long ago, we mostly lost the cardholder data through magnetic stripe, and people would skim the magnetic stripe on the card in point of sale. And nowadays, people are doing more skimming of e-commerce transactions because chip and pin has made that skimming magnetic stripe doesn't really help. And then secondly, that this is a way that cardholder data is exposed to criminals. And so there are two new requirements in DSS version 4. The first one is 6.4.3, and that's a prevent or protect type of requirement. The idea of it is for organizations to actively manage the JavaScript that's on their payment pages. What we found was when you looked at a lot of forensic reports and reports of why organizations had skimming attacks, was that in a lot of cases, They didn't understand the amount of JavaScript that was actually running on their payment pages. And that's because it had been added by marketing, or some developers had found a module that they quite wanted to use. And so the amount of JavaScript that was on the payment page was actually really not visible to people in information security. And so the biggest point of 6.4.3 was to say organizations need to get hold of that JavaScript and ideally reduce it, and therefore reduce the attack surface. And if you see me present before, or if you see me present at the community meetings, I'm always talking about the size of the attack surface with your first-party scripts and third-party scripts and tag managers and fourth-party scripts. Anywhere that a script comes from is part of your attack surface, and some of that you have no control over because other people manage it there. So the real idea of 6.4.3 is to reduce the attack surface by saying that scripts need to be authorized, that you need to work out how you can work out that the integrity of the script is okay, that you keep an inventory, and there's a justification of why it's necessary. And I know these sound like tick box compliance requirements. Have an inventory, write a justification. But the idea is to make people think about, do we need that script on that page or not? Because if we don't, let's get rid of it and reduce or minimize our attack surface. That's 6.4.3. The second new requirement is 11.6.1. And if you're familiar with PCI DSS, this is really similar to the file integrity monitoring requirement that's been there for years. And what this says is you need a change in tamper detect mechanism to see if you've got compromised script, or the HTTP headers, which might be the way you're doing security, changes. And you need to do this, it says, at least every 7 days or periodically. The idea here is that if you've got a list of approved scripts that's on your site, but it changes, you need to just make one simple determination. Was that an authorized change? Actually, it's two determinations. Was it authorized? And has that change resulted in the scripts now exhibiting malicious behavior? So those are the two very simple requirements designed to reduce the attack surface, have people manage their JavaScript, and then notice when it changes and work out if that change was a good change or a bad change. That sounds dead simple, doesn't it? But when it actually comes to it, we've discovered actually it's quite hard to do JavaScript management. As I say, the requirements say you need to make an inventory, but to do that and then to work out how to manage it, what we've discovered in most organizations is that actually the key thing to understand is how the business processes in your organization work that allows JavaScript, or gets JavaScript, not just onto your payment page, but onto the whole of your e-commerce website. And so when we do an inventory, and we have a free tool that will give you an inventory, or you can go to your website and press F12 for the developer tools on your browser and get an inventory of all the scripts that are on the website. And the thing to do is to work out these things. One of these questions is by far the most important of any of the others. And if we were actually in a room, I'd have a little quiz and you could guess which one it was. But when you make the inventories, like, here's the script, what's it for? The second question is, does it come from you? Does it come from your own environment, or does it come from a third party? The third question is an interesting one, is, do we trust it? And the answer might be, actually, now we've done the inventory, we have no idea who runs that website. We haven't, if it's a third-party one, we have no idea what that script actually does. So we probably shouldn't be trusting it just yet. The really important question is, who owns it? What I mean by that was, if you were to take that script off your payment page, who in your organization would ring you up or send you an email or a Slack and say, hey, what's happened to that piece of script that I stuck on the website? Or more importantly, if you wanted to remove that script from the payment page, who would you need to go and ask? And then the final question is it necessary for the payment page? But the most important one I've discovered in doing consultancy, and at JScrambler we've discovered working with organizations with JavaScript on their pages, and we've been doing this for a number of years, not related to just payment pages, is to work out how that JavaScript got there and who in the business is the owner for it, because that's the person we're going to need to talk to say, actually, can we not have that script on the payment page? Because I don't think it's doing anything improve the payment journey. It's not necessary for the payment page functionality, which is what the standard says. But more importantly, if we remove it, then we don't have to. If we remove it from the payment page, it could be elsewhere on the website. If we remove it from the payment page, it's not part of our attack surface. So that's the first thing in terms of making an inventory. The second thing is to understand your current business process for working out how scripts get added to the payment page. I mean, who can do it? Is it just development? Or is it the marketing or digital department because they're using something like a Google Tag Manager or Insight Tag Manager or Adobe Tag Manager, which allows them to add tags, which is marketing speak for random bits of JavaScript, to the website. The next thing is that operating in any sort of change control? For instance, if it's done by development, does it follow the standard SDLC? If it's done by infrastructure, does that follow their standard change control procedures? If it's done by marketing, if it's done by marketing, do they have change control procedures? Or did someone go in and just use the tag manager to add some JavaScript to the page? And is that change control it's under, does it look like anything? Does it look anything like requirement 6.5 in the requirement in PCI DSS, which has got fairly prescriptive ways of saying these are the attributes that your change control ought to have? The next thing is, if it's third-party JavaScript, is the third party where that JavaScript comes from part of your third-party management process, whether that's your normal business risk third-party management process or the one that you're using to comply with requirement 12.8 for managing third parties that can affect the security of cardholder data. So if a new piece of JavaScript gets added that's coming from a third party, what vetting has been done of that third party to give you some confidence that that script couldn't be changed without that third party's knowing about it? And the answers to these questions will hopefully give you a series of flowcharts. That's what we usually do, is we do some flowcharts to work out how somebody has an idea and then it gets actually as a script on the payment page. Because what we found for a lot of organizations, and if you read the standard doesn't say whether you need a pre-approval workflow or a post-approval workflow for JavaScript that's on the payment page. It just says that the JavaScript on the payment page needs to be authorized. But the question is, for a lot of organizations, can you put a bottleneck in place to authorize all JavaScript before it gets added to the payment page? Or actually, is it more pragmatic and sensible to use the change and tamper detection mechanism to notice instantaneously that new JavaScript has been added to the payment page and then work out whether you need to approve it or unapprove it? And we found a lot of organizations where actually the website's not under the control really of IT anymore. It's under control of marketing, who will add JavaScript to the website. Is that post-approval is practically the only way that control of JavaScript can be achieved in many organizations. And the reason for doing this, for doing this exercise of doing the inventory first, working out who owns something, and then working out the business processes by which new JavaScript gets on the website, is that when you are coming to plan to meet requirement 6.4.3, you're going to have a number of different technical options. The first of those is something called content security policy and sub-resource integrity. Now, I'm going to be very quick about this, but we can go into this in more detail later or offline if anyone wants to know. But CSP is an HTTP header that says where a browser is allowed to load scripts from. So if you say it's only allowed to load scripts from your domain, then any other scripts just won't be loaded. And sub-resource integrity is a way of checking that a script that you like and approved hasn't changed. Basically, for the script file, you generate a hash. So you generate a hash of the JavaScript, and you include that in the script src tag. And then when the browser reads that third-party script, it also computes the hash, and it makes sure the hashes match. CSP and SRI is actually great. You can meet the PCI DSS requirements using CSP and SRI. And frankly, that was one of the intentions of the way it was written, that you could use these two tools that are built into the way that the web works. The problem is that the if you've got third-party scripts on your website, you often don't know when they change, and therefore the hash will need to change, but the third party's not told you that their JavaScript's changed. And unfortunately, SRI doesn't sort of give you a warning that something's wrong and send you an email. It just stops the JavaScript working. So CSP and SRI can work very well if you've got very tight pre-approval workflows where every change, even that's a third-party change, has to be authorized. You can create a new hash, you can change the website. But it can be very resource-intensive because there's some great research that actually says a lot of JavaScript changes on a very regular basis, daily or even more frequently than daily. The second thing you can do to meet the requirements, certainly for the notification, is use scanners or synthetic user monitors, so that something comes in and looking like a bot and looks at the website and says, "Hang on, that script has changed," or "Hang on, that HTTP header has changed," and alerted you. You can use tools like JScrambler provides to protect your scripts. The most important thing to do is because of these new requirements in PCI DSS, there are lots of organizations now that are offering solutions to help organizations meet these requirements. And so the first thing I encourage you to do is, once you've worked out your workflows, work out if whatever you're looking at will fit in with the way that your business manages JavaScript. Because we all know that if we try and implement something that doesn't work the way our business works, there's probably little point because the business will fight against it. The second thing I'd really encourage, that having worked with organizations doing this, is whatever tool you pick is to do a proof of concept first. So well before you actually make a purchasing decision, do a proof of concept. Does this fit in with the way your organization works? Does it actually break your website? Does it break the performance of the website? And then a final question, and JScrambler's tools can do this, is as well as alerting when there's a script change, JScrambler can actually block malicious activity. So if you want to be really safe and, for instance, allow marketing to be able to continue adding any, I shouldn't say this, but any random script to your website, if you use a tool like JScrambler's web page integrity, that will actually block all access to the payment fields apart from the JavaScript that's supposed to access those payment fields, which gives you a degree of protection while also allowing flexibility in terms of many people being able to add JavaScript to the website. So those were the three things that I really wanted to say today. I said it was a very short presentation. I said 8 minutes. It was actually 16. I'm sorry. If you want to talk more about PCI DSS 4 or talk about some of the issues we've seen in managing JavaScript, which turned out to be a lot more complicated problem than I ever thought it would be, we are at the North America PCI SSC community meeting in Portland, Oregon, in about 2 weeks' time. I have never been to Portland, Oregon, so I'm quite looking forward to it. And we are also going to be at the European PCI community meeting in Dublin, which is at the end of October. We'll have a booth, if you're American, or a stand, if you're English, at both of those events. And now that's all I wanted to talk about today. Now I'm really happy to take any question about PCI DSS 4 or just JavaScript and PCI DSS 4. And I'm not sure if I'm going to see questions in chat. The question from one user is there going to be a recording available? I'm going to wait for someone to give me an answer on that because I don't know the answer. Yes, there is a recording going to be available. That was an easy answer. Brilliant question. And if you can all see the questions or not. The question is, if I use my payment provider's iframe to process payments, so you have the website. I know doing iframes with fingers is weird, isn't it? You have the website, your payment processor gives you an iframe. That's where the payment fields are. So your website doesn't store, process, or transmit cardholder data. Do the new requirements to prevent skimming attacks apply to you? That's a brilliant question. And the answer is, you'd assume no, because you don't have a payment page. But the answer is actually yes. If you look at SAQA, which is the SAQ you would use if you were using a payment provider's iframe, it's very clearly that the requirements also apply to the parent page of the iframe. And let me explain why that is. Because you think, well, that's really interesting, isn't it? That because if you have JavaScript in the parent, it can't actually access any of the fields with the payment data in the iframe, and that's currently true. The problem is we've seen a lot in the industry. We've seen a lot of attacks against this. There are two sorts of attacks. The first is what we call a frame overlay attack, whereby the criminal will hack the merchant's website and add their rogue criminal JavaScript to the web page. And then what happens is that and I need some visual tools here, but imagine this is the iframe where you would, let's do it over here, the iframe where you would enter the cardholder data. The criminal floats their iframe exactly above it, so it looks exactly the same, and captures the cardholder data. So that's the first attack, which is called an overlay attack. The second attack we've seen lots of, not lots, but we've seen quite, it's an attack that the criminals know about. It is that the criminals break what we call same origin policy. And what they do is they break they compromise the merchant's website, because the merchant's website, remember, only SAQ controls to it, not lots of security around it, or not lots of mandatory security. And the criminal then changes the code, and what they do is they get the merchant's web server itself to request the payment iframe from the PSP, and then they serve that from the merchant's web server. So it's a sort of like an attacker in the middle attack. What happens then, of course, is that the iframe and the parent page have both come from the same origin. And therefore, any JavaScript working here in the parent page is allowed to get access to the contents of the payment fields, so they can do their skimming attack as well. And so if you look at SAQA, a new version of SAQA came out in December last year. It's on the PCI DSS website as R1. It makes it very clear that these two new requirements, 6.4.3 and 11.6.1, both apply to the payment page, which comes from the payment service provider, sitting in an iframe, and the parent page from the merchant as well. So thank you. That's a really great question. And the next question is, are there any changes in v4 that are directly related to cloud infrastructure? And I would say not specifically. I've not done a search for the word cloud in the standard. But while the standard was being drafted, you'll notice a lot of the wording has changes. So, for instance, it doesn't say firewalls anymore. It says network security controls. When it talks about router configuration files in requirement 1, it now talks about things like Terraform build files, like environmental build files. And also, if you look at the way that the scoping is defined in requirement 1 for instance, the DMZ or DMZ, depending where you are in the world, the requirement for a DMZ or a DMZ has been removed because a lot of cloud architecture doesn't take it. So it was rewritten, and we have to acknowledge that DSS, because of its age, because it came from 2008, is quite infrastructure focused as a standard. But when it was rewritten in version 4 to be as neutral as possible, to make it much easier to do cloud implementations. The second thing is that you'll have noticed, if you look at DSS, that for every single requirement, there is a defined requirement and then a customized approach requirement. The SSC have talked many times about being very conscious that some organizations, because they might use more advanced technologies than DSS expects, sometimes struggled to meet DSS. And this was very clearly in cloud environments. And so for every single requirement, we have a customized approach objective. And the customized approach objective means if you can meet the objective of the requirement, then you don't have to use the defined approach. And a user has just pointed out, because I can see, is there's currently a PCI SSC SIG, or a special interest group. And there's usually a SIG running every year, a special interest group, that's working out the best way of addressing cloud and how cloud relates to version 4 to add some context to the standard itself. Remember, the standard you try and write is technologically neutral as possible. The information supplement for the SIG will come out probably early to mid next year, and that will have some guidance. There's also still a very interesting scoping guidance document that was released a few years ago. So I'd encourage you, if you're a participating organization, to still get involved in that special interest group. And if not, keep an eye out for it, and also look for the FAQs and other documents on the PCI DSS website. There's a question now that says, why is the customized approach so hard and complicated? I don't know whether to disagree with you and say it's not hard or complicated. One of the reasons that PCI DSS is a pretty well-respected standard is that the requirements are very specific and prescriptive, and there is a robust QSA assessment procedure. So sometimes with other standards where it says just, meet this objective, it's very much up to an organization to say, well, we meet the objective. When the customized approach was being talked about, and there are some great recordings of Lauren Holloway and Emma Sutcliffe from the PCI DSS talking about this on the PCI DSS website and on recordings on the PCI DSS website. One of the things that everyone was very conscious about was not diminishing the standard by just allowing the customized approach and someone to go, yeah, that must be fine. And so the customized approach has got a very rigorous assessment process behind it. The concept here is this, that number one, the organization firstly needs to do a risk assessment to make sure that their way of meeting the objective is not any riskier than the defined approach. And then the second thing they have to do is to work out how they have to test it. How will you test that the control that you've designed, which is different to the prescriptive one, how would you test and prove it was working? And once you've done that, the QSA also has to work out a testing procedure, because if you look at the standard, every single requirement has a testing procedure against it. The testing procedure for the QSA will say, look at something, speak to someone, read something. So check and see how something's configured, interview a person, look at documentation. Well, we wanted the same level of rigorousness with the customized approach as we did with the defined approach, so that the QSA's got to work out, actually, how could they write a testing requirement that matches the sort of testing requirement that you see in the standard? And then the assessor can execute that test requirements against the controls that the organization's put in place, and do that on an annual basis so it was rigorous and repeatable. So that's why it's complicated, because we didn't want to drop the robustness of assessment. And someone in chat has said the SIG, whose name I did completely forget, is called Segmentation in Modern Architectures, which looks at cloud and segmentation and what becomes in scope and what doesn't become in scope. Yeah, and as someone said in chat, the important thing with a customized approach is it requires you to be able to do risk assessment. It requires you to be able to justify why you're doing controls that meet the requirement. And so it's not something that's designed for mature, and I don't want to say level 1 organizations and service providers, but it was effectively designed for organizations that have probably a risk department in their information security team that can make these judgments, and a compliance team that can work out how to test it. It was not designed for smaller organizations to say, oh yeah, we do this. It was designed for larger organizations that are doing innovative security. And probably the best example I have is if you're properly doing zero trust, and if you're using zero trust in your organization, you'd find it hard to meet a lot of the PCI DSS defined approach requirements, whereas you should be very easily able to meet the customized approach requirements. But then you would have to work out how you test, how you satisfy yourself and how the assessor satisfies themselves that actually the controls do the job they're supposed to and that they're working. Okay, I've seen no more new questions, and so let's wrap this session up. I hope it's been useful for you and stimulating. If there's anything you think about, you think, oh, we should ask that, you can find me on LinkedIn and just fire me a question. I spent my last 13 years answering random questions from people about PCI DSS. So I'm more than happy to do that. If you'd like to learn more about JScrambler, then look at our website. And if you'd like a free inventory for your website, then we can give you a free inventory for your website, which will start that business process. And remember, the important thing is working out who owns that JavaScript. If I wanted to remove it from the website, who would I go and ask? So thank you very much for your time. I hope it's been useful and hope to see you in person at either the American or the European Community Meeting. Bye now.